Okay, hello everybody. Welcome to the Project Doc. I'm your host, Brian Locke. And the Project Doc is kind of a dumb name because I kind of envision this being more as like a, I don't know, bring a hack or I can hear myself back. Where is it? Here we go. Yeah, so it's kind of more like a show and tell, like Adafruit do, but just a little bit longer form where we can dive into the nitty gritty of the project a little bit more. But also, if you are having a problem with a project, feel free to bring it along, and we'll see if we can help you out with it. If you're interested in joining, there should be a couple of spaces towards the end. There is a link in the description to the Discord. So if you just ping me on that, I'll add you to the chat in Discord that has the link to the StreamYard stuff, and we'll bring people on one by one to talk about their projects. And first up, we have Colin Hickey. Hello, Colin.
Hey, Brian.
How's it
Thanks for having
going?
us on. I'm good, yeah, you?
No problem. Yeah, no, I'm good. Why don't you introduce yourself? Where are you from? What do you do? What do you like?
I'm Colin from Newcastle, the northeast of UK. Kind of been making a while, mainstream IT, but love making stuff and ESPs and different bits and pieces like that. Normally toys for the kids mostly, but started branching into some PCB design and little bits and pieces.
Awesome. So you have a project that you're going to show us today.
Yes, if I can. I haven't physically got it yet, so if I share my screen,
Sure.
I'll share this one.
I'll bring that up when it happens. Or
Yep.
Okay. Yep.
So yeah, I along with a lot of other people, saw a video that Thomas Salander did recently, which was the SD Wi-Fi by FSY Tech, which basically has a PCB which is the same form factor as an SD card with an extra bit added on the end, which adds some smarts to it, as it were, which is an ESP8266, which runs a WebDAV server. So that allows you to wirelessly transfer your files to the printer. And that's pretty cool. And his take on it was a little bit mixed, and so was mine, because it's handy to be able to transfer them, the files, but then you don't get kind of any visibility into what's happening. So I had a bit of a look around, and was one of the guys on your Discord server had mentioned something called ESP3D. And this is the software here, which just runs on an ESP8266 and allows you to connect to your printer, start a print off the SD card, allows you to check everything that's going on. But one of the issues with that is the connectivity. So what I've kind of done is I've tried to solve the issue of the connectivity of ESP3D and then mash it together with the FSY Tech.
So for people who don't know, what are the issues with the connectivity?
Yeah, so the issue of the connectivity is that you need to connect to the RX and TX on the printer, so the serial lines, and those aren't readily broken out. They are on the AINSI boards on the Prushas, but on things like the Creality and the Enders, they're not broken out. So you've got to kind of like scrape back traces and then start soldering on the boards. And it's, yeah, I don't think I'd fancy it, It's a bit of a recipe for disaster. Could be a good way of destroying your board. So one thing I've looked at, based on the work that Aaron has done, which I think he's tags ATC 14 something. I can't remember his exact tag, but
it's ATC 1441. It's Aaron Christopher.
Oh yeah. So he's done some amazing work with the CH55X series chips. So I've looked at using the CH554, which can run in host mode. So then what you'll do is you'll plug your printer into this board, and then that'll not only power the board, but then that'll do the conversion for the RX and TX for the serial. So then that'll allow ESP3D to talk to the printer without having to be anything invasive, and it can just sit outside. It's powered off it and everything as well. Still got to see whether it provides enough power, but it should do. It also depends on the printer setup as well, how much it can provide. So just a bit of testing. So that was the mainstay of it. It's got a micro SD on there, so you still get the SD card functionality. And this is the part that I borrowed from or took inspiration from the FSY Tech project, so that you get the local SD card on board, but then it's the PCB type design, which then plugs in. So you can upload your files wirelessly through the web interface, and then you can start the print off, and it's streaming it straight direct off the SD card, so it's not the ASP streaming it, because you can't have issues there if you connect with the web interface. You can have that with a Pi, so you're definitely going to have it with an ASP. So I've kind of tried to get the best of both worlds, as it were.
Yeah, that looks cool. And what do you need to make the PCB a certain thickness to go into the SD card slot, or is 1.6 kind of the right size anyways? Or?
When I measured it was about 1.6. I used a janky ruler when I did that measurement because I've lost my calipers. So I've only ordered 5, so we'll see.
Yeah. And did you order them bare PCB, or are you getting them assembled or anything?
I've just went for the bare PCB, just because I might need to. Yeah, I'm not too confident on running it first time. I've also ordered a breakout board from Ali that's got the CH554 on with all the points. So that's kind of my known good benchmark, as it were, for any issues that I might run into with chips or just the design or whatever.
Yeah. No, this looks really cool. Like I have Octopi set up, but I basically use it as much as this. Like, I don't use any features on it at the moment other than like upload and start the print from somewhere.
Yeah.
So that's pretty interesting.
That's the other side of it, is that I do use Octoprint as well, and it's a brilliant piece of software and it works well. But if you've got more than one printer, the costs start to mount up.
Because you should use a full size Pi for Octoprint as opposed to a Pi Zero. So the cost isn't $10 or whatever. It's like what, $35? Is that what they started? Plus your SD card, and they need a decent power supply.
Yeah, I was just going to say that. Yeah, decent power supply, and it starts to mount up. So if you could get something like this, and I don't know what it's going to cost, $20 or something like that.
Yeah, and so like the USB that we see up the top here, that's going to plug into the printer is going to plug into that.
Yeah.
Right. So like I think my Ender has probably a micro USB. No, I think it's a mini USB.
Yeah.
If I'm not mistaken. I think it is a mini USB. So like I plug my mini USB into the Ender 3 and then that into this.
Yeah.
And then you'd probably have to get like there is like SD card adapters to micro SD, isn't there? Like ribbon cables almost.
Yeah, I was torn on that because I had 2 different ways of doing it. I could have either done this with a USB mail plug, so that could have plugged directly into the printer. But as you've just mentioned there, there's different types, so that's why I went for the socket, and you can just use whichever cable you get with the printer. But again, for the SD card, it was whether to make it micro or full size, and just for kind of durability, I went for full size. And like you say, you can get adapters if you need to get one, and it might not be a bad idea as well. I don't know about the durability of having this hanging out the side of your printer as well.
Yeah, no, I think it's a really cool project. So what? Yeah, you have it ordered now. It's on its way.
Yeah.
What's the biggest thing you think might go wrong?
The hurdle's going to be the CH554, getting that going. There's some good examples out there, and Aaron's done some great work. I reached out to him as well, just as a sounding board to see if I was crazy, and he thinks it's more than doable. And to be honest, it's one of the more simpler uses of it, just to break out the RX and TX. So that's something I've got to work on. But if I can get that going, and actually looking on the forums and the Discord for the ESP3D, it's been suggested in the past, but no one's really put a big amount of time in to get it working. And so people have had a similar-ish idea, I discovered after I started this, which is the same with most ideas, but no one's actually got it down to a workable solution, basically. So
cool.
Yeah.
Right. So where can people follow along to get progress on this, Colin? Where will you be posting about it?
I'll be posting it on Twitter, and hopefully I'm going to get back on the YouTube train, and I'll start getting some videos out soon. So this was a nice, gentle introduction to YouTube again.
Yeah, very gentle. Although I don't have visibility to see how many people, but there's a lot of people talking in chat, which is more than I thought there would be. Seeing as it's on my second channel, and I did a terrible job of like advertising it. But yeah, no, thanks so much for sharing. I'm really excited to find out more about this. So keep us posted.
Thank you.
I'll update the description after this with Colin's link. If Dave Darko could post it in the chat for his Twitter, that would be good, so people can follow along if they like. And thank you for sharing, Colin, and I'll catch you.
Thank you.
Okay, so that was Colin and his ESP3D adapter board. So it's a pretty cool project. Next, we have John McRae. Am I pronouncing that right, John McRae?
Yeah, that's me.
That's you. So, John, tell everybody who you are and where you're from.
So, I'm John McRae. I'm living in Colchester now, although I've been traveling around over the last few years, but much more settled now anyway. And as you can see from the mess behind me, fairly active in terms of making stuff.
Yep. Messy desk means messy mind, is it?
Yeah, pretty much.
Mind ever. Yeah. So you have a project to show us.
I do. I think probably what I'm going to do is share my screen first of all.
Sure.
Let me see how this works. Being a newbie to this kind of thing completely.
Oh, no problem.
So for some years now, I don't know if that's coming up.
It's showing up now, yeah.
Super. I've made my own battery management system for looking after the health and welfare of lithium battery systems. And currently I've got this one connected to a big 200 amp hour 12 volt bank that's sat on the desk beside me actually. However, there have been a few problems over the years. I started off, I'm going to change screens here. And I want to show you this. Now, since it's a medical channel, I thought you'd probably be interested in this. I don't know. Oh no, I meant this. So everyone's seen one of these. This is an ADS 1115. You get them from China. They're £1.50 plus postage now. And lots of people, if you type ADC in Arduino, that's what you're going to find on the internet. That is the de facto maker ADC. If you don't want to use the one that's built into the Arduino at 8-bit, is it?
It's 8-bit on an Arduino, yeah.
Yeah, ESP8266 and ESP32 at 12-bit, I think.
I believe so. Yep.
And not terribly accurate. So the problem
that would be the reason you'd use an external one, right? Is that like either it's too low of resolution, like for the regular Arduinos, or they're not that good.
Exactly.
the other case. Yeah.
They're not that good. And if you look at the various videos out there on YouTube, you'll find lots of very experienced makers basically putting aside the Arduino and the ESP8266 ones. They've gone for the ADS 1115, meant to be 16 bits, really only 15 bits because one bit is taken up with a negative sign, and really quite noisy. And in fact, I had to oversample to get a reasonably stable and noise-free measurement. I had to oversample, like taking 5 or 10 samples of each channel, and it was taking a lot of time, and it wasn't very accurate. The best I could get was like 6 to 10 millivolt accuracy. So I started looking around again, and I came up with something different. In fact, I have one here. I'll share the screen again. The different camera. Yep. Where's my camera?
You're a real pro YouTuber. You have more cameras than I do.
Why? There it is. Sorry.
No problem.
Okay, so I came across the MCP 3428 is the one I'm using.
Yep.
And so I built up a little board. I'll get it the right way up. And I made it pin compatible with the ADS 1115. And the benefit of this over the ADS 1115 is it truly has 4 differential channels rather than straight direct sampling channels. If I turn it over, you'll see that towards the bottom you have channel 1, 2, 3, 0, 1, 2, and 3. Yep. And you also have negative 0, 1, 2, and 3. They're the extra pins that you wouldn't find on an ADS 1115, because everything on the ADS 1115, you can have 2 differential channels or 4 direct channels.
Yeah.
So I made this.
Nice.
It's very good.
So it's longer than the first one you were showing, right? Because of those extra negative pins, is it?
Yeah. Let me just grab the other one, and I'll put them side by side so you can see.
Yeah, so it's basically pin compatible with a little extra.
It's pin compatible with a little bit extra, and the bit, if you don't want to use the differentials, then they can hang over the end.
Yeah. It's not a big deal. You just solder less headers onto it, right?
That's right. And basically, to get it going, all you need are these the 1 capacitor and 2 resistors.
Yeah.
And all the rest of the components on the other side are either to give you pull-ups for your I2C, or to allow you to switch direct sampling or differential. They're just solder bridges.
Yeah.
Direct or differential for each of the channels.
Yeah, cool.
So I'm just going to switch back now to here, and you'll see that if you go down to the bottom, well, the big picture here in the middle, the noise is like it's plus or minus 1 millivolt. It's really low, and that is with no oversampling at all.
Wow, yeah, that's really good.
So it's really good.
How expensive is the IC?
Oh, it's like $3.
That's not too bad.
It's not bad at all, and that's in the onesies. You know, you're buying one at a time.
Yeah.
But the other thing is there's an Arduino library for it.
Nice. That's always. I always pick my ICs based on that too.
And it was really simple. It was literally a 10-minute job to just change the library over and completely change my my sampling code, and it was up and running.
Nice.
And go on.
No, I was just about to say that's great. I love it when it works out like that.
Yeah, I know, it's really strange and rare.
Yeah. You have to celebrate these ones because it doesn't happen often.
No, it doesn't. And you'll probably think I've been cheating here, but actually it is live. So if I
Nice.
switch a load on it samples every couple of seconds.
You can see it straight away show up there in the delta on the right, could you?
Yeah, on the right, there's a little imbalance in the cells, and then the cells are starting to go down because I switched on this big bright light.
That's really cool.
Anyway, so there you go.
Nice. And you brought us pretty much exactly to the 10-minute mark, John. So that's great. Thanks for sharing the project. So where will you be posting about it, or what's your future plans for the project? Or
well, I've been thinking about that. I've wanted to do a video about it, but it's like one of those things I haven't quite got round to, you know.
know the feeling. Yeah.
But I've got a whole bunch of boards, so I might just do a video, and yeah, if people want to head over to my channel, then I will post a video in due course.
Yeah, make sure you comment on the stream so people know where to go to get your. But I'll update it. I'll update video afterwards.
Sure.
Or I'll update the description afterwards with your channel link. But John, thanks very much for sharing. Good to talk to you.
Yeah, good to see you in person again.
Yeah, it's been a while, I think. Yeah. All right. Thanks a lot, John. I'll talk to you again.
Okay.
All right. So that was John with his external ADC project using a different chip that I forget the name of, but it seemed to be quite a good one for not a whole lot extra money than the cheap ones. So next we have Keaton. I think is it Keaton or Ketan?
Neither. It's Kethen.
Neither.
So it's but
Kethen, isn't it?
Yeah, there's an invisible H.
Okay, perfect.
Yeah.
I have troubles with my H's even when they're there, so this should be good.
Don't worry, I'm sure you relate with your last name. Plenty of people calling you Brian Lough or something.
Lough, Lough, whatever. Yeah, doesn't bother me anyways. But Kethen, tell everybody who you are, where you're from.
Yeah, so I'm an electrical engineering student in my last year at university. I'm in Vancouver in Canada, and I spend probably more time than I should on like little hobby projects and things like that.
You are prolific. You share a good bit on the Discord, and yeah, you're definitely one of the more prolific ones. I'm like, this guy is in final year of engineering, and he's still doing more than the rest of us. So
I call it productive procrastination, but
I know the feeling.
So the thing I wanted to share, I'll share my screen here. So I'm not sure if you saw it. So what I was working on is I wanted to make a switch mode drop-in, like a DC to DC converter replacement for like a LDOs and things like that. And that's what I did with these little super integrated DC converters. But one of the things I realized was that like if these pins are going to be like an interference issue, and I haven't really done anything with castellated holes, or every time I've used SMD pins, they just like rip off the board and stuff like that. So I guess sort of what I was wondering is like, what do you looking for outside opinions on like how should I approach this? Should I sort of extend the board and do some castellations, or try a different approach or something?
Well, me and RF are not friends. It's something I try avoid altogether. Or what would you be saying was the issue? It'd be impedance, is it? Or
no, sorry, just clearance, like physical
clearance. Yeah.
Like because say like wait, hold on. So say you were mounting this flat and soldering this to the PCB or whatever.
Yeah,
those pins would get in the way. Was my
I got you.
my concern.
Yeah.
So it's just sort of a mechanical aspect.
Mm. I guess if you were mounting it flat, would you then have the option of just going straight down with regular headers? So rather than, with the regulator, the regular one, you would be like soldering it like a head straight up and then bending it down. But I guess with this, you don't have to do that, right? You could put it straight down to begin with and, solder just straight headers, as in like you don't need to replicate the fact that the legs are following, the way you have it there, that orientation,
Right.
they're continuing on from the board, but they could just go at a right angle to the board. Like I know these are right angled ones, but
Yeah.
like if
My
you
thinking
use
was
straight through ones.
because if you use like straight through ones, I guess if you don't have to use this plastic bit, but I was just like, then it's going to be offset from the board.
Oh, you would the mountain hole wouldn't line up anymore, I guess. The
Yeah.
big one at the top, like.
I saw someone in the Discord had mentioned doing something like a combination of like SMD pads with like a castellation on the end. I was wondering if anyone has like experience with castellations and whatnot.
Yeah, I don't. One of my reasons being that they're really expensive. Like, as in, if you add a castellated hole to a JLC order, like your $5 PCBs are suddenly like $40 PCBs or 30. I don't know exactly what the cost is, but they're really expensive. But like for small manufacturing, especially something like this, I guess you could always use Oshpark. I'm pretty sure it's included with the price of that. Yeah, the other thing that kind of sprung to mind is like, I don't know, you see some people do it with programmers and stuff, like with pogo pins, where they just have like a straight kind of header or pogo pin where they have like a pad. It's almost like an SMD pad or whatever, but they solder, like if you could imagine that you don't have the black bit of plastic there and it's just straight down on that part of the board. Yeah, like as in you're almost soldering, directly where you're drawing your line there. So how are you finding the performance of, so this is a visual. Have you ordered one or?
So I've ordered boards. I haven't gotten them yet. Like I made this like a few days ago. So
this is
I
a
guess
beautiful render as well.
This is just an Altium. This is wrong render. That's the render.
This one, I mean, like,
yeah.
This is super nice.
Yeah, I make more renders than I do PCBs at this point. But
but they look good. They look good. And that IC that's doing the conversion, is that expensive?
It's about, so in like single quantities, it's $2 or $3 Canadian, so off DigiKey. So my idea with this is like, I might eventually sell it, but the main idea is just every time I give anyone like advice on a board, it's always like replace that LDO with a DC-DC converter. And this sort of eliminates the thinking for them. It's just like, hey, you just have to plop this in and then it'll work.
Yeah, I could definitely.
So it's a little more expensive, like than in a comparative LDO. But the idea is like, hey, now you're not wasting 10 watts in an LDO or whatever.
Yeah, I could definitely see that. Just one thing that I'm thinking of as well. So if you did the first suggestion I had with like this straight down where it wouldn't line up anymore, I guess you don't. If you knew ahead of time that that's what you were going to do, like if it was going to be a lie down one, I guess the PCB could be longer than the body of the regulator is. Like, so you've matched, like if you go back to your render, like you've the matched size by size now, but like you could extend the PCB size of your new one so that the holes are where the legs would be. When you solder it in and bend over the legs, they're not right up against the body, right? As in
Yeah,
they're not
I
right
think
up against the body of the regulator.
that sort of gives me an idea of like extend the PCB so that it could do what you're saying, and then also make it like a break off type piece. I mean, depending on
You could have
that way you
mouse
can
bites.
do either. Yeah, sounds like a good solution.
We've solved it. I don't think this is definitely not my area of expertise. There's some people in the chat that are also mentioning some stuff. So I can see one here. If you could just insulate the back with another board that heat sinks the ground true but covers the pin headers, it's not a possibility.
Could work. Then there's just the second board involved.
Yeah, it increases like production cost massively if you start doing something like that. Anything non-standard, but yeah. So this is cool. So where do you share your stuff? You're on Twitter.
I'm on Twitter. I'm always around in the Discord posting pictures and things, and then GitHub. Everything I do, I like it to be open source, so it's all on my GitHub.
Cool. So if people have suggestions to Kethen for this project, feel free to. I'm saying this, but maybe he doesn't agree. But feel free to tag him in my Discord or on Twitter, and I'm sure he'd appreciate some feedback.
For sure. All right. Thanks, Brian.
All right. Thanks so much. Okay, so we don't have anyone else at the moment. So if you want to join, feel free to jump into the Discord and share, or just tag me in the Discord and I'll add you to the super secret Project Doc waiting area. And Doc is like Doctor, Doc McStuffins. Some people were like, oh, I think it's about documentation. And I was like, that was not my intention. But while we're waiting, I'll show you something that I've been working on. So as always, I'm absolutely terrible at recording these screens, but we'll see what we can do anyways. See, OBS. What do I want to do here? I want to share desk plus me. All right, except where am I? I'm missing. Here I am. Somewhere. Okay, so here is the screen. So if you saw my last video, the scrolling LED display for Smarter Every Day. So I'm going to send a message to this and hope that it works. I was doing a lot of messing around with it yesterday, so including trying out Wi-Fi Manager and it could be in config mode. It is in config mode, a Wi-Fi Manager. So if anybody has any questions in the chat while I connect to config mode of Wi-Fi Manager, feel free to say hi or do something. And my closet door is shut. Yes, I actually remembered to close it this time. I nearly always forget. Like this is the room I work from as well. And like nearly every time I jump on a Zoom call, I'm like, oh, that stupid door. You'll also notice my 3D printer there. That is an ANET A8. It literally never printed once successfully. It had a broken heating element as far as I could tell right from the start. That if you jiggled the wires, it would work. But then as the head moved around, it would stop working. And so I was fed up of having a assembled printer I was literally never going to use. So I took it apart because the motors, which you see at the front there's 5 of them, and possibly the threaded rods are probably more valuable to me than the printer was. There's also a power supply, but I'm not sure if I'm going to use them because some people were saying that it's absolute garbage, and I don't doubt for a second that it is. All right, so I'm just putting in Wi-Fi Manager details. I hadn't used Wi-Fi Manager in the ESP32, and you need to install the alpha version. And other than that, it's pretty similar. I checked out a couple of other ones, and they were just so much more complicated. So I went back to good old Wi-Fi Manager. Okay, let's see. Okay, it seems to be working here again. So let's jump to Desk plus Me. I say it seems to be working, but it doesn't seem to be doesn't seem to be displaying anything. Did I turn it off maybe? Oh, there we go. Not sure why it's yellow. It shouldn't be yellow. Is it on power-wise? Interesting. Cool. So this is working really well. Yeah, but one of the nice features I added to it, and you won't be able to see because I'm guessing there's something wrong with the colors of it, is I enabled emojis to be drawn. Oh, that's drawn fine. Maybe I just have the color set wrong. Yeah, it's not really focused right, but you get the idea. There's a rocket. So that was way more work than you'd think it would be. Like the project of getting, so what I'm doing to update is messaging it from Telegram. And like the project to get the scrolling text being updated from Telegram was like literally an hour. And then like to get the emojis showing up took me like, I don't know, 5 hours, maybe 6. Like it's basically going, hey, I see that rocket emoji. I'm going to strip you out, and replace you with three spaces. But instead, and like I'm going to draw a picture in that space of a rocket emoji. So yeah, it works out all right, but you know, it's fine. Hey, we've got someone new added to the stream, so let's let them join in. Hello, Dave.
Hey, Jason.
Dave, tell everybody who you are and where you're from.
Oh my God. I'm Dave. I'm from Berlin. I sometimes do videos for Element14. It's been a while. But yeah, I like to design PCBs and such as well. And I have no idea what I'm here to show. Maybe I can show this. So
you can show whatever you want.
This is what I did today. I designed a little box. And I'm really not a big fan of 3D printing boxes because it takes ages and then you have something like this. But I made a compromise because I have like 25 kilos probably here of PLA. So I thought maybe I should print something big. And yeah, I have also lots of these 10 by 10 PCBs laying around because I was a fan of the dirty PCB standard that they had.
I didn't know anything about this. So what is it that it was cheaper if you got a 10 by 10 PCB, like literally cheaper than a 9 by 9?
Well, yes. Well, 10 by 10 was the maximum for the price, like $5 for.
The JLC is the same in terms of like, yeah. Like I mean, I have not designed anything above 10 by 10 for this exact reason because it just increases PCB price. Yeah.
Well, it doesn't do it that much, but I can
get to that later.
But the thing with Eagle is that you normally can only produce boards that are 8 by 10 centimeters, and the I just said it. What was the board company? Dirty PCBs.
Dirty PCB, yeah.
Yeah, they have this the standard of 10 by 80 boards, and then you have 4 millimeter radius and holes of 3.2 millimeters and stuff like that. So it's kind of a standard, and they called it the sick of beige standard, and then they had the acrylic tops and stuff like that. So yeah, I designed a lot of boards in that shape to get the maximum space out of the pricing. and I have a lot of leftovers. So I thought I made this box, and I'm printing it like this. And then I can use the leftover PCBs as the bottom of the big boxes. So that way I'm not printing the whole bottom that is constantly going around and taking up a lot of time of the print. So
I was about to I misunderstood where you were going with all of this right till the end. I was about to be like, okay, you've left over PCBs, but why are you building them such a tall enclosure? I didn't realize that the PCB was part of the box, not that the box was for the PCB. That's I'm a big fan of mixed material things with for 3D printing. I hate 3D printing pretty much. Like I love it in some ways, but like I hate printing that box just because it's like, oh, this is going to take, like, what did that take to print? Like 10 hours?
That's 4 hours.
Is it in vase mode or anything? Or?
No, it's 0.25 millimeters of layer height in Prusa.
Yeah.
And it's three. It's a wall thickness of 3 layers side by side.
Yeah, so like still 4 hours it's a lot. Like when you could buy, something. Like I know you already have the plastic, but like when I'm looking at it, I'm like, okay, I have to design this thing up, and then I have to do this, and then I have to send it to the printer, and if it fails, I have to, blah 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 blah. But I love combining 3D printing with other stuff to make like this bigger thing. Like is in like at one stage we wanted to we have our kitchen table up against the wall, but there's a radiator at one leg of the table and there's nothing at the other leg. And we were like, okay, like when you push it in against the wall, it keeps tilting because one leg can go in further than the other leg. And we were like, okay, we could 3D print something that goes around the leg that's close to the wall to kind of like keep it away from the wall. We're like, oh, but this would take so long to make it strong enough. And it was like, oh, what we could do is like 3D print something that held a piece of timber in it, so like the length to get to the wall could just be timber because it doesn't need to be the 3D printing. And I like that stuff. I think one of my first big projects I did on YouTube was the Zelda chest. And that was another mixed material one as well, where I used I 3D printed the metal parts of the chest, and then I used like lollipop sticks for the wooden parts of the chest. I thought it turned out pretty nice. I sent it to a Reddit Secret Santa. You've got a nice vibe going on in your room with the red and green lights and stuff.
The backlights aren't on. Normally I have them and then everything shows in there, but now it's kind of a mystery because it's messy. So let's talk beside the mess.
I should have done that too. Just turned off the lights. Thank you for coming on. And that is a really good idea to reuse some of your old PCBs as bases of boxes. Like I also have this box of like just PCBs that, what am I going to do with these? The main
if you have mounting holes, then go for it.
I do have some mounting holes. Some of them are panelized though, so they wouldn't be that strong for being the base or something. Like the main reason I hold on to them is like potentially to use them as a stencil, like the jig of a stencil holder or whatever, a solder stencil. But some of them are still okay. I sent one of these to a maker recently it's for CH552 boards, because they were looking to work on them. Never arrived to them. They like designed PCBs themselves and ordered it. I got there before my ones did. Just post is awful. Post is awful. Right, Dave, thank you for joining and keeping me company on this evening. And have a good night.
Is anyone else here, or do you want to end the
Yes,
stream?
I have one more at least.
Okay.
Okay.
Remember to promote the Makercast.
I will remember to promote the Makercast, but there isn't a link for it yet, right?
I mean,
I'll promote it anyways.
yeah. Let's just say
Okay.
Zach Friedman and everybody freaks out, and then we're good. All right, cool.
Perfect.
Thanks for having me.
Bye, Dave. Okay, thank you, Dave from Berlin. And next up, possibly last up, is Deshepu.
Hello.
Deshepu, tell us who you are and where you're from.
So I live in Switzerland. Originally, I'm from Poland. My name is Radomir Topieralski. And I do a bit of a hobby electronics thing. I did a few useful things on Tindy. Right now, not anymore because the plug is making it difficult to do logistics, so I'm pausing it.
I know the feeling, yeah.
But that doesn't mean I can't design new things and keep them on the back burner and maybe if they work out. So yeah, the thing I wanted to show is this project.
That's adorable.
Yeah, it looks like a cat, probably, or a pig, or whatever.
My first thought would be cat.
Yeah, so there is a bit of a. So, do you know what this is?
It looks like a whistle, like an ocarina or something.
Yeah, exactly. That's an ocarina. People probably know more this kind of ocarina.
Yes, I was like, it looks kind of like
Zelda.
Yeah,
ocarina.
that's the only reason I know it.
Yeah. So the thing is, those ocarinas are much smaller, while they still have very nice sound, and they are much easier to learn to play. They are almost as easy as Irish whistle, as tin whistle.
Everybody in Ireland pretty much learns the tin whistle in national school, and when you learn, like, it's awful sounding. When someone is learning how to play, it sounds like a bunch of cats in a bag or something.
On the other hand, it's like the simplest instrument you can learn, right?
Yeah, they are simple.
Simplest one. I mean, the fingering is a bit more complicated. We only have 6 holes, 4 on the front, 2 on the back, so you have to do combinations. It's not like on tin whistle where everything is like in order. Cover. So you have to learn the combinations.
Can you play it?
You can use the tabs for a tin whistle on the ocarina.
Yeah. Can you play that? You're being requested to play a song.
No, it's late in here.
Okay, yeah, no problem.
That brings me to the reason why I want to build this.
Okay, yeah.
Basically the same thing, and a 6-hole ocarina. There are 4 touch pads in here and 2 on the back.
Yeah.
Like a 6-hole ocarina.
Yeah.
And there is if I remove this, there is a pressure sensor here.
Yeah, just 1 second. I'll make you the big dog. Can I do that? I'm sure there's some way I can do it. Hold on.
I think everybody.
Yeah, here we go. Yeah.
It's not that interesting to see a pressure sensor. It's just a metal can with a hole in it.
Yeah.
But the idea is that you put a piece of a straw on top of it, and then it can detect you blowing into it.
Nice.
And then it has this Sandy 21, one of my favorite chips recently.
So you're MIDI-ing back to your computer then.
Yeah, so exactly. It uses CircuitPython to generate MIDI stream.
Yeah.
And the idea is you keep it connected to the computer, to the USB, and you play on it. So I have it physically finished, and there are some small changes I will need to make in the final version, but otherwise I'm pretty happy with this. I have 2 problems that are more like, so one is a hardware problem that I think I can solve in software, and one is a software problem. the
Till
purely
you can solve it harder.
yeah, I will also solve it in software if I solve it. But the software problem is that MIDI protocol was basically okay. We have a piano. How can we make it speak to a computer?
Mm.
So it has this notion of keys that you press, and it basically sends to the computer which keys you are pressing.
Mhm.
And a woodwind instrument basically only has one key.
Yeah.
That changes the
Yeah.
one key, but it changes the pitch.
Mm.
And the thing is, I really want to really have nice music on an ocarina. You do this bending thing where you uncover a hole a little bit
Mhm.
to get various effects, and that's why I use touchpads, because with touchpads I can detect.
You can adjust. Yeah.
Yeah, so I can do bending. The problem is that the MIDI protocol only allows you to bend about 2 notes up and
Okay.
down. So I cannot do this where you play one note by blowing and just bend that note depending on which holes you cover.
Yeah.
I need to disable that note, release that key, and press another key when you press when you cover another combination of holes. But I still need to do bending when you uncover partially a pad. So this is going to be a bit complicated, probably. And
sounds it, yeah.
But yeah, it's what makes the project interesting.
So it's really simple. So the SAMD, well, sorry, I say it's really simple. There's a lot going on, but there's not a lot on the board.
I mean, hardware-wise, yeah, this is just 6 touch pads, and a pressure sensor.
And the SAMD21 can do the touch, capacitive touch on its own, is it?
Built in exactly on 6 pins. So I'm lucky here.
Yeah, perfect.
I was planning to do a standalone version at some point as well. That would have
with a buzzer or something, is it, or a passive speaker, is it, or?
Yeah, something like that. The problem is one of the pins that does touch is the DAC pin.
Ah, yeah.
So I have it already taken. So I would need to switch the microcontroller to something else. Or do the touch with a separate chip or whatever. But for now, I want to finish this. The hardware problem I have is that the pressure sensor I'm using is for weather stations and stuff like that.
Okay.
And when you blow on it, it immediately shows you increasing pressure. And that's perfectly great. But when you stop blowing, it takes about 30 seconds to stabilize back to zero.
Okay. Yeah. So it's just the whistle is just continuing on for 30 seconds.
Right. So the thing is, when you blow again, it goes up again. But the zero is now
it's
shifted.
Adjusted. Yeah.
So I think I can do this in software where I just look at the difference and not at the absolute value of the pressure. Which also is a good thing, because then you can play in an elevator while you are traveling.
So how
it would calibrate at the current pressure when you start. And then
how when you do, so I understand that. So you're going to, like, you're at a certain pressure and then you blow again and it'll be above where you are. But when you stop blowing, how would you know you've stopped? You won't know that you're above.
Blowing, it starts.
You slowly see it decline. Okay, yeah. So you could detect.
Again, it will again be like a big step up.
Yeah, I get you. Yeah, so it's like, you can detect it has stopped blowing. It just won't go back down to that zero value. And that seems pretty. That's a really cool project. Did you like the concept of the straw and the pressure sensor? Is that something you came up with yourself, or did you see someone else do it? I've never seen that.
I've seen a few electronic woodwind instruments on hackaday.io, but they used a flow sensor. So that's a pressure sensor that has 2 inputs. Input and output, and it measures basically the flow. But then I started looking at how those sensors are built inside. And basically, Venturi tube, the thing that airplanes use to measure the airspeed.
Yeah.
So I looked at it, and turns out if you have a pipe, and then you have like a smaller pipe, and you put a pressure sensor where they change, you can detect the change in speed of the airflow that way. So this doesn't look like it, but actually the part of the PCB where you put the straw on makes the straw narrower. So that's why it works.
That's amazing. And like, did you get that right with your first PCB, Rev?
No, it's actually funny because I started with a pressure sensor on a module.
Yeah.
With DuPont cables and everything, and I just used plasticine to attach the straw.
Oh yeah.
And when I blow on it, the pressure would go up.
Yeah.
And with this, after I received the PCBs and assembled it all, when I blow on it, the pressure goes down.
Yeah.
I have no idea why. It's mechanically a little bit different, but I can still. I only care about the difference. So
yeah.
And
that's awesome.
I can't get this to work, I can look for a different sensor. That's one thing, and I can also use a microphone and measure the noise of the air.
Yeah, that'll work pretty well.
So I have options here if I can't get this. So yeah. Of course, now that the physical thing is done, I have very little motivation.
It's always the way. You've done the challenging part, and now you just have to turn it into a product, right?
As you can see, this still has plenty of challenges. There's challenges where I can use my fingers, so it's not as interesting. Well, not. It's still interesting. It's not as easy to do.
Yeah. Well, if you ever make a standalone version, I think my daughter would absolutely love it. So I'll be first in line on your Tindy store for it.
I will keep that in mind.
We can be the beta testers. Thank you so much, Deshepu. Where will you be posting about the project? Or I think I saw Dave Darko share a link in Hackaday.io.
Yeah, I put all my projects on Hackaday.io basically. So
cool. And you can follow Deshepu on Twitter as well. Is another place to check up what he's been on to.
Actually, Mastodon. Twitter is just for commercial stuff.
Oh, okay. All right. So Hackaday.io is the place to follow you. So
Hackaday.io or Deshepu at mastodon.technology.
Cool. Right, thank you so much, Deshepu.
Thank you.
Right, so that was Deshepu with his digital, I suppose it's electronic 6-hole ocarina instrument I only know from my childhood of playing The Legend of Zelda, Ocarina of Time. What an interesting project. Straight away when he showed the cat, I was like, what's that thing sticking out the top? And it was a straw. Who would have thought? So we're at an hour, which is all I was going to stream for. I hope you liked the format. Let me know. Let me know if you did. If there's things you'd like to see changed. If you're interested in coming on next week, tag me in the Discord, and we might give it a go again. I liked it a lot. We've one last person apparently. Where did you get that wig?
Nice show, man. I'm Hackgiver, don't you know?
Oh yeah,
I bought that for the Element 14 thing.
That competition where you made like a Switch
Game Boy thing emulator with Raspberry Pi in it. Yeah, but I'm not here to talk about that. Anyway, I liked the show. I hope everyone else did.
Yeah,
I just wanted to hop in again.
I loved it. I felt a bit out of my comfort zone with some of the stuff we were talking about, because I don't know a lot about them. But I thought this was really interesting, so I'm happy with it. So yeah, I think we'll be continuing it on.
Nice. Do it on the
Oh,
real channel next time, maybe.
maybe this was episode 0, so episode 1 maybe on the real channel. All
Nice.
right. Thank you so much, everybody. I'll talk to you next time. Bye bye.
I'm so sorry.